right, folks, welcome back to the last lesson in our unit on circles, where we talk about a thing that probably should be talked about at the beginning of any math class. But how we're going to end it, we're going to end the entire math class on a thing that we should begin any math class with. Something called a locus. Not a locust, the bug, a locus, which is a description of a set of points. So what we're going to talk about is what is a locus, describing it in a plane, what happens when we have two conditions, and what happens when we go into space. Now this one's going to be interesting, so I'm going to make two videos, because the first is to ease your mind on what exactly is a locus. So we're going to start off with notes. Now, what is a locus? It is simply a description of a set of points, and that is it. So in any class that involves graphing, no matter what, and I would argue even elementary school, we should be talking about locus, the description of a set of points. Let me tell you here's how. Remember the good old equation of a line, y equals mx plus b, and how to graph that. Okay, so m is your slope, and b is your y-intercept. So what I'm going to do is real quick graph that for you super fast so we can understand what a locus is, and I'm going to convince you that we've worked with one in the past. So we have our equation line y equals mx plus b. That means 3 on the y-axis is where we begin, and then from that 3 we're going to count a slope of negative 1/2, which means down 1 and right 2. It could also mean up 1 and left 2. And then when we were graphing that line, well, we would graph that line, wherever we connect the points and all that stuff. And what we didn't know, because we didn't use this word, what we didn't know is that what y equals mx plus b is a locus. This equation is a locus. It is the description of a set of points, and that's it. This equation is the description, or the graph is the description of the set of points that meets that criteria. So the ordered pair 0, 3, 0 for x, 3 for y, meets this equation. Okay, the ordered pair, the other point that we drew, 2, 2, 2 for x, 2 for y, meets that description. And every other infinite point in between. So this, in fact, is a locus. Okay, but we never knew that. But now we do. So I'm telling you before, the locus is a description of a set of points, and that's it. We've worked with it in the past. So basically, I'm just, excuse me, writing that down. Sneezed on camera. There we go. So it's the description of every ordered pair xy that makes this equation a true statement. Okay, so we would think, how many ordered pairs would make that a true statement? Infinitely many ordered pairs makes this true. Infinitely many ordered pairs makes this true. So we have a graph to represent it. So equitation, I just realized I misspelled this word. The same holds for every equation of any graph that we've ever graphed. We were using a locus. That's what a locus is. Okay, so I don't want you to be afraid of the word. We've used it. It's just a description of a set of points. Having said that, what we're going to start doing is using our imagination now. So now we have to start thinking and using our imagination to figure out locuses, loci. So what is a sketch and description for the locus of points in a plane that meets this criteria? Points that are 1 centimeter from a given point C. Can you visualize what's happening? If not, then let's start from the very beginning. Point C. Here is point C. And what we're going to visualize is all of the points that are 1 centimeter from that point. So let's imagine we had a given distance. We'll say that was 1 centimeter. That's a point 1 centimeter from C, let's just say. And if that's 1 centimeter, well, maybe, there's a point out here that's 1 centimeter from C. And maybe there's another point, maybe out here, that's 1 centimeter from C. So if we start visualizing what is happening 1 centimeter from the given point C, what's going to go on? A circle. It is a circle with all of the points 1 centimeter from that fixed point C. So we're going to sketch it, done, and we're going to describe it. That's what we've done. It's a circle with radius 1 centimeter. That's what it is. It's a circle with the radius of 1 centimeter. That is the locus of points 1 centimeter from a given point C. So that's all it is. We're using our visualization and our thinking skills. So let's try this one now, a little bit more confusing. We're still in a plane, okay, so we're still working in 2 dimensions, but what would be the picture and description of all points that are 1 centimeter from a segment now, segment AB? If you can't visualize that, let's start from the beginning. Let's make a segment AB. So you create your segment AB, and you start to visualize what's going to go on 1 centimeter from that segment. Well, we can have maybe 1 centimeter out this way. We could have 1 centimeter out this way. We could have maybe from B, right, 1 centimeter out this way, and from A, 1 centimeter out this way. So all of these points that are happening, 1 centimeter from the segment AB. But look at what's happening with A and B. What's going to occur? Well, from B, there's 1 centimeter out this way, and there's 1 centimeter out this way, and there's 1 centimeter out this way. So what's happening around B? It's like wrapping around. It's like a semicircle, and the same thing will occur around endpoint A. So what then, right, if this is what's occurring, that is 1 centimeter from the segment, what then would it look like? It would look like this, which is basically kind of like a rectangle but with 2 semicircular ends. Okay, not an ellipse, but a rectangle with a semicircular end. And so maybe that's how we would describe it, right? Semicircular ends around rectangles. But that is what a locus is. You're just describing a set of points that meet that criteria. So let's think of another one, and we'll call it a video. We'll come back with some more challenging stuff. So let's use some reasoning, right? The previous problem we sketched the locus of points in plane 1 centimeter from a segment, right? Remember that, the segment. How would the sketch change if we're going to find the locus of points 1 centimeter from line AB? Ooh, line AB. Let's draw that. Line AB goes on forever, correct? Correct. You remember that from lesson 1 of the year. So line AB goes on forever. Now remember, from segment AB, we had that like tubular, rectangular thing with semicircles. What's going to happen with a line AB? This is going to be interesting. If you can't think of it right now, again, start drawing. You should be able to visualize this right now, but if you can't, let's just start drawing it. It's going to be 1 centimeter from that line. So we can have, 1 centimeter this way, 1 centimeter there, 1 centimeter there, 1 centimeter there, like maybe even like way off the graph, 1 centimeter. It looks like if we're going to go up from the line, it's going to be another line. It's going to be another straight line. That's going up from the line, right? But that's not the only 1 centimeter away. There's also below the line AB. What? So we go 1 centimeter down here, and 1 centimeter down here, and 1 centimeter down here. We would have another line. What is going on? But does that not fit the description of points 1 centimeter from line AB? It totally fits that description. So what are we looking at? We're looking at 2 parallel lines that are 1 centimeter away. Okay, so notice what changes when we had a segment, right, where the kind of points wrapped around the locus wrapped around the endpoints, versus line AB. Now we have 2 parallel lines. So be it, but that's just important to think about. So that is a locus. What I want to do is come back in another video to start talking about multiple things that can occur, and we start talking about space, which gets really fun. So hang tight. We'll be back in another segment.